Good afternoon. I'm Zen. I'm the co-founder of Factory 39 and Balabook. I'm a full-stack developer for the last 15 years, and I've had the great luck of working for some great companies in the past who have given me some amazing experiences that hopefully I'm going to be able to share with you a bit of today. For the next 20 minutes, I will endeavor to help you cope with the struggle of dealing with legacy code. And let me start by saying that legacy systems are not evil. We all have to deal with them. In fact, if you're a professional developer of any kind, at some point in your life, you'll get this big monstrosity that you hate landing on your lap. Over 70% of IT budgets are actually spent every year maintaining legacy code. So we're gonna kind of talk about today, we are gonna look at whether you should modernize or potentially throw it out and rewrite it, like some techniques of how to figure out what does it even do, adding some tests because you're probably getting some untested crap that you have no idea what it does, and then some strategies for potentially improving, monitoring, deploying it, and in generally keeping things going. So to start with, do we modernize or do we rewrite? Do we throw it out or do we try and keep it running? Well, I mean, if it ain't broke, don't fix it, right? Like if it works, if the company you work for is happy and there are no problems, don't do anything. Like maybe add some tests, maybe I don't know, polish it up a bit, have a good way of actually deploying. If you don't need to change it much and it's just there, don't do anything. Fine. Because the reality is most rewrites fail. In fact, I have this great example from a very large company that I had the great luck of working for. They have this big, massive reconciliation system written in the mid-2000s, processes about $100 million worth of transactions every month. And it was massive. Like when I started looking at it, like don't get me wrong, it's not built in something completely ancient. It's still Java, like not like in some dead language or anything like that, arguably. That particular piece of software is now on rewrite number 8, and that's since 2005. So it feels like every couple of years, the team has this big, great idea about how slow and crap it is, and is like, okay, let's write it again. They spend about a year or 6 months doing a proof of concept. Proof of concept's cool, looks great. They start actually trying to do more on it, and in fact, today they are still maintaining the version from 15 years ago along the 7 other iterations that they've done since then. Speaking to them recently, they're on number 8, like they're working on it now. It's gonna be great. So yeah, like one thing, some things that we should get out of the way. Legacy systems embody years of domain expertise, right? Like they have all those little mistakes that you every day in your job add into your code base, like this hack that you thought is we're gonna get rid of next week. All those things just accumulate over time, and then trying to rewrite them is basically not gonna happen. The reality is businesses rarely have the attention span needed to follow through with a rewrite, and the reality is rewrites are expensive, so they're very few companies are going to dedicate their resources in one go to actually make that happen, because it is going to disrupt their existing workflows, right? Like if you come up with a new system that you thought is a good rewrite, it's going to miss 2, 3, 5 critical features that the business needs to run. So they're going to be like, oh no, we need to keep it. We need to keep the old thing running. And then now you end up maintaining two systems, and in 2 years down the line, your system's now the new legacy system. This promise that we as developers sometimes try and tell ourselves to convince our managers and convince our bosses that we're going to have complete control. It's going to be so fast. It's going to be so simple if we do it in this new shiny language. It's an illusion. It really doesn't work most often. And if you do actually manage to rewrite the whole thing and it replicates all the features, guess what? You're probably the new legacy code and you've replicated the same problems. That's just a hard reality, sorry to say. Does that mean I should never rewrite? Well, depends. I mean, my default these days is that you should always default to modernization. You should always explore ways of incrementally modernizing the system. You can rewrite small chunks of it. You can, let's say we have this bit of functionality in that legacy system that doesn't work quite right. Maybe we can extract that out. You can do that bit by bit, and over the years you can incrementally kill code. Eventually, the old system's probably not going to end up doing much, and you might actually end up being able to kill it, or you might not even need to kill it at that point. Who cares? Like if it runs and it does one small thing, it doesn't matter, right? But yeah, very often what I get, especially from newer developers, is this kind of behavior. This is going to be so much better if we redo it in TypeScript or insert new framework of choice there. And I mean, sorry to say, but like let's take a step back, some deep breaths, and let's evaluate. Like, should we rewrite? Well, is the existing system unstable? Does it break often? Like, is it causing financial harm to the business? Are your customers calling and complaining about how terrible the experience you're giving them is? Is the technology that it's built in completely unsupported and dead, incompatible? I'm not saying keep around the COBOL system, although you might actually need to. There are ways to do that if you are brave enough. Has the business significantly changed over the years that this system has been around? The reality is, like, sometimes we do keep, like, some businesses keep legacy systems because they do this one bit of functionality out of the 200 bits that they used to do, because it just does it. Like, if you're in that position, maybe it is worth rewriting, just because the business fundamentally changed. We're no longer doing what we used to do 15 years ago. We're doing something completely different. We don't really need this piece of software anymore. It's okay. We can move our database of customers in Excel. It's going to be fine. We don't need to keep it around, but you get the idea. Is it so tightly coupled that whenever you need to iterate on it, or whenever you need to do a change, it constantly breaks production? You're basically completely unable to touch it in any shape or form. Or does it genuinely have any security risks that we can't mitigate? Every system has security risks, right? Like, security is all about compromises. But are the security risks present, like something that we cannot mitigate? My general point is, and what I want you to take away from this is, you should focus on outcomes, not the technology. Technology changes, people change, teams change. Focus on the outcomes. And think of your users, think of the company you work for. Don't just be excited to work on something new and shiny. We all want to do that. If you do, whatever you decide to do, be prepared for things to get worse before they get better, especially if you rewrite. You're going to make things a lot worse for yourself, for the company, for the customers, before you make them better. And again, sometimes that's okay. With that out of the way, let's try and understand this thing we inherited. What does it even do? Well, okay, to begin with, let's begin with what we have. It really isn't, it's not just code, it's an API, a tool, a mobile app, an old Windows app, or whatever it is. Use it. Be a customer of it in some shape or form. Try and understand what it's meant to solve. Talk to the stakeholders, ask questions, dig into the code's history. map its dependencies. If you're lucky, read any existing tests and documentation. You probably don't have that, but if you're lucky, do make sure that you go through the history. So again, I want to reemphasize this. Use the damn thing. It is unbelievable how many developers I've met in my life that write software that's in production serving customers that have never actually used it, that have never touched the button. You ask them to actually give you an example, and unless they always give you the same example that someone else wrote in their integration tests. They don't even know how to open the app. Like, don't be like that. Use the thing that you're meant to maintain, support, build. Be a customer. Dog food your own code. Ask questions. This is very, very important. Talk to people. What problem is this system solving for you? What are the critical features? What do you use every day? Who relies on this system and what? One of the things we used to do very often, and we do to this day, is go and sit with the people. I used to we used to work on a support piece of software, right? Like, it was meant to support people at a call center. We'd spend days going up to the call center, sitting and being literally a call center agent, using the thing just to understand what it does and how they use it. What's the pain point when they use it? Ask questions. This will answer most of the questions that you have about an old system. Look at the history. Git log, like if it's in version control, and these days, even if it's a very old system from the 2000s, it's probably in version control in some form. Read the history. It's very easy. Like, you can get a lot of insight and get into the sense of and the mind of the developers that came before you. Like, release here doesn't have to be Git. Like, even the release history, if like any notes. What does it talk to? I identify its pieces. There are a lot of automated tools, Sonar, DepGraph. Like, you can even, if it's an API or a service that talks externally, you can even use Postman to just try and grab all of its external, like, understand what does it talk to, who does it talk to externally. That will help you kind of map it out if it's a completely unknown thing. Make sure you inventory all of its components, databases, APIs, the config, where does it live? And again, read the tests and the documentation. If you have this, it will give you more and give you a better understanding about how how the tool is meant to work than most other things. And at this point, I would focus on integration and kind of behavioral tests rather than unit tests. You don't need to understand how this one function works at this point. We're just trying to get a sense of how the thing is put together. Now, we've done a lot. We've done a bit of research. We've gathered the things. Where do we start? Well, if you don't have tests, I would start by adding them. And even if you do, I would still write my own. I would still try and get some automation going so that I can get some safety. Tests are all about you feeling safe. And yeah, there's really two types of tests that I would worry about here, and they're very similar. One category is the characterization tests, and the other kind of tests are really black box testing. They're very similar kinds of tests. You effectively test at the edges. You treat the system as a black box, really, and you say, when I do this, then that thing should come up with that. Think of it at a system level. Like, the main difference between the two kinds of tests is characterization tests are really meant to test your observations. You went to the call center and played with the with a tool, so you can write a test. When I press this button, that message gets fired, or when I open the app, I should see a splash screen. Making a very basic example here. But whereas black box testing are testing the correct behavior. Characterization tests, you are basically testing what you expect to, what you've observed it doing before you touched it. And you can use lots of tools here. Like, there's lots of automation you can already build. I hope a lot of people are familiar with things like Selenium, like browser stack tools, things like Appium if we're talking mobile apps, or even like good old bash scripts if you're poor. I mean, you don't need to get fancy is the point. I hope no one's confused yet. So what's better? Again, do both. The main idea is to help you document and validate that the thing you've inherited does what you expect it to do. It will help you validate that you've collected from your stakeholders, that the things you've collected from your stakeholders are behaving the way that you expect. Next, I would really encourage people to go and do some exploratory refactoring. Now, most people that have heard the word refactoring think of it as we'll do it to improve something. At this point, we still don't know what we're dealing with really, and I would focus on exploration and learning. Start with a goal, an area of the system, and really time box it. 30 minutes is enough. If it's a big system, you don't want to dig yourself into a hole. Set an alarm, in fact. Use ID automations liberally and focus on quick wins, on like small things, reorganizing the code, looking at really long methods, bad variable names, focus on like grouping things so you can understand them. Keep testing continuously. You have a bunch of tests that we've written hopefully by now to validate that our changes are actually making sense and are not actually breaking things. And take notes and document your findings, obviously. Your alarm rings, 30 minutes have passed. Now git reset hard, throw away all those changes. The idea here is not to fix anything. The idea here is to get a thorough understanding of the code, because the best way to understand code that you don't know anything about is by touching it. In fact, touching code gives you a psychological sense of ownership of that code. Like, it makes you feel more confident just because you touched it. And if you can do it with the safety of some tests and the knowledge that you're just going to get rid of everything that you've just done, it's really powerful in making you confident in being able to change stuff in the future and getting an understanding of it. So can we teach an old dog new tricks? Well, maybe, probably. Why not? Let's try and get closer to the 12 factors. 12 factors are really a way of thinking about how to build a modern app, especially an app that wants to be in the cloud. It focuses more and is more relevant to kind of service SaaS type applications. But a lot of the teachings of the 12-factor app are applicable to most systems that we work with. And you can't get all 12 factors for legacy systems. It's going to be hard, and that's okay. Let's try and get us close. I would, in fact, focus on a few basic things. I mean, obviously, it should have version control. If you don't have version control at this point and we've come this far, we're doing it wrong. Isolate its dependencies. Start isolating its dependencies. Like, a lot of what legacy systems turn to be put together on like servers that have been handcrafted, relying on system dependencies and so on. Try and create an isolated environment. And you don't necessarily have to do it through the framework and language that it's using at this point. You can use something like Docker to put together something like isolated that would allow you to have confidence that this thing, we can move it around and it's going to kind of work. Start treating its backing services as resources. Like, that's a great refactoring that you can start doing. It's making sure that you can swap around things like databases that you might be using, different APIs and so on. Start treating it as attached resources and having their config of how to switch them around in the environment. Many legacy systems have like big variables at the top that kind of globally defined config, and it's really hard to change unless you do a release. So try and extract config to the environment. Move to reproducible environments. That is a really big one and very simple these days. Infrastructure as code with tools like Terraform and so on are commonplace. All you need to do is just get a YouTube tutorial and you're probably good to go. in many cases, but make sure you have a repeatable environment for dev, staging, and prod, and you can easily do it. And one of the big ones is get your logs to be streamed. A lot of legacy systems have their logs in files, and that makes it really hard to actually tell what it's doing. As a developer, you have to go manually on servers and so on to kind of try and debug. Getting your logs to be streamed somewhere centrally that you can control is a really big one. And if you're refactoring, if you're already in the process of changing things, adding metrics will be really powerful and eye-opening in how to help you target the areas that need performance improvements. You can use lots of tools here. There's lots of online tools that are basically free to use if you want to host them, and you don't need a lot of resources here, like Grafana, Loki. They're all publicly available. You can download them free, host them on a machine. Especially if the system's not serving tons of traffic, you don't need to pay anything really. They'll run on a Raspberry Pi. Things like Prometheus for your metrics, or like good old Elk Stack. And if you're working for a company and can convince them that paying for a solution, New Relic works great still. And a lot of these tools you'll find effectively libraries that will automate most of it. You've done all of this now. Invest in some meaningful dashboards for your system. And I want to stress meaningful. You don't need to build them from scratch, although having your own custom dashboards for a tool to a point that they make sense is great and will really give you a new level of being able to deploy things and scale something. But there are a lot of templates, like especially if you go on Grafana Cloud, like this, there's a lot of templates you can just get like install and get going without doing much. Like have some meaningful dashboards to have some eyes. And very importantly, build a pipeline. CI/CD has like the concept of CI/CD has been around for ages, but a lot of apps still won't be doing CI/CD. You should build a pipeline so you can commit a change, have your tests run, get that change automatically pushed to a staging environment, then be one click away from pushing it to production. Make sure you build a pipeline. Let's wrap it up. Modernize by default. Add some tests for safety. Super important. Before you do anything else, talk to people, get some context, start adding tests. Use refactoring to learn. Build pipelines. Have eyesight. Most important of all, provide value, not technology. It's all about what can we give to our users, our customers, the business we work for, not just the shiny tech we can use. Legacy systems are not evil. Any questions? Oh, yes, sir. Right. Yes.
Yeah, regarding this legacy system, what's the definition of legacy? At which point should I consider my system to be legacy?
It's a good saying about this, that you know you're growing as a developer when you see code that you wrote like a year ago and are like, oh shit, who was the idiot that wrote this? So that's a great question, actually, because a legacy system is basically anything that was written in the past, really. Because if I wrote something a year ago and I'm a year better now, technically that's a legacy system. And that and the reason I feel that's a great question is because the example that I gave of the company that rewrote their thing 7 times, basically they were treating every partial rewrite as basically a legacy system, and now they've got 7 of them. So, yeah. Yes.
Fantastic talk. I think you could break this up into multiple talks to talk about monitoring and all sorts of different things there. One thing that I'm interested in is you start something brand new now. What are the steps that you take to make the inevitability of it becoming legacy easier to deal with?
For me, the number one thing is having tests around it. something is tested, and I'm not just talking about having unit tests. I know a lot of companies just think testing is unit tests. No, there's lots of layers of testing you can do. But if it has tests in a way that they describe the intention behind each element of the code, that immediately, when you have a new team 3 years from now, because people churn and leave, they can just go to those high-level tests. They don't need to worry about figuring them out. They can just read what they do, and then things are broken out. Like things start making sense, because having tests as your documentation and not relying on outdated PDFs that somebody wrote when they designed the thing 3 years before it was built. That's the most current. That's the best way. That's the best step you can take, I think.
In the world of AI, where developers will write the code and generate the tests, which means you're testing your bugs, how do you, as a CTO, convince your engineers to write their tests rather than generate them?
I'm really lucky, because we're in a team that test-driven development and BDD, behavior-driven development, is something we practice every day. We don't really use AI to generate tests. I'm not saying it's not going to happen at some point. Obviously, AI is advancing quite fast now, but I would much rather have AI generate production code than generate tests. Because if you can't describe the thing you're talking in a test description sentence, then you're not ready to write it or solve it. Like, you need to be able to describe the problem you're solving first.
Any other questions?
Okay.
Thanks for the talk. Quick question. Is there any of this advice that we can use in migration? So we migrate from one to the other, and some that we can't, let's say.
So if you're migrating, let's say you have one system and you're migrating from one framework to another. Okay, well, in essence, that kinda qualifies as a rewrite in a way. There are many ways to approach a migration like that without it basically being a rewrite. And it depends on what kinds of technology are we moving. Like, there are a lot of companies that are going from things like, I don't know, Spring to Spring Boot, for example. That's a very straightforward migration. But you can apply basically everything we talked about in principle to migrations as well. So if you have a specific example that you want to talk about after the fact or in the break, just catch me. I'll be around. Cool. Anything else?
Thank you so much.
Cool. Thanks.